Today, we're going to talk about how some of the biggest software companies in the world prevent disaster and tragedy from happening. Hey everyone, my name is Trevor, and today we're going to be talking about some designs that you can use for hybrid, active, multi-cloud, globally distributed software. This is a topic that I've personally learned a lot more about over the last 5 or 6 years. It's a really fascinating subject because every time you launch an application on your phone or you enter a website in your browser, chances are you're accessing a system that leverages one of the methods that we're going to talk about here today. I think this is, at the very least, an interesting topic that all IT practitioners should have a basic understanding of. And even if you're not a day-to-day IT practitioner and you just understand the very basics of technology, it can be really cool to start to understand how these large global scale systems work, because at the end of the day, these things drive our lives, they drive our economy, and frankly, they're the most interesting systems that have been designed probably in the history of the world. So there's a world where if you need to design your own application, you could also use this video as a starting point to do a little research about the different options that are available, and then maybe you could do your own independent analysis or reach out to experts like myself or others if you need to dig deeper and understand the inner workings of these solutions that we're about to discuss. Let's get started. We're going to be looking at 4 different designs that can be leveraged for a multi-site application. So I'm talking specifically about software that is being served to end users from multiple physical data centers at one time, okay? If you're not sure exactly what that means, stick around, you're about to find out. Today, you might hear applications like this referred to as active, globally available, multi-cloud. Listen, there's a lot of buzzwords that you can use to describe what I'm about to show you, but at the end of the day, all it really is designing software and infrastructure in a way so that if you lose a whole site, if some disaster happens, whether it's a natural disaster, a military disaster, a power disaster, that your application will continue running and your end users that use your software wouldn't know the difference even if you lost an entire data center or an entire region in a public cloud. The 4 different designs that we're going to discuss, a DNS-based approach to load balancing between multiple data centers. We're going to be talking about a really cool system called Tanzu Service Mesh and this idea of a global namespace that also enables us to load balance traffic between multiple physical infrastructures. We're going to be talking about Anycast routing, and then finally, we're going to be talking about overlay networking and data center clustering, or Metro-Datacenters. The idea of this is not to be an exhaustive guide. I'm going to run through each of these to give you a high-level understanding so that way you can get started and dig deeper into these topics as you see fit. The first and definitely the most common option is what we call global site load balancing or global server load balancing, but really what this is DNS-based load balancing. This is a system that is designed to route users to different infrastructures, and it's all done with a control mechanism that is DNS. Just to walk you through what you're looking at, I've got a few different data centers here, one in Asia, one in the Americas, one in Europe. These are the infrastructures. These could be a data center. These could be a public cloud. This doesn't matter. This sort of solution will comply with any sort of compute infrastructure that you're using. There's generally going to be a load balancer component that's site local, and we're also critical to this solution is what we call an intelligent DNS tier. I'll explain a little bit more than that in a second. All right, so how this system works is actually sneaky kind of simple, okay? You build your application to run in multiple infrastructures at one time. These apps can have their own IP space. They can be running really completely independently of one another to a certain extent. But what we do to control user traffic and decide which data center we're going to send a user to when they access our application is all based on DNS, okay? So let's say that this application that I've got spread throughout the globe is called GSLB.foo.com, okay? What's going to happen? The user is going to open their web browser or their application, and it's going to route them to this FQDN, this URL, right? But what you do is during the configuration of this sort of solution, you effectively configure kind of like a DNS forwarding, if you will, to say, hey, when a user asks about gslb.foo.com, let's go ahead and send them to one of these 3 intelligent DNS servers. And 3 is an arbitrary number. It can be more than 3. So that way, those intelligent DNS servers can decide what data center to send that user's request to, okay? So that's going to happen. The very next step in DNS is that now we're going to reference to one of these 3 intelligent DNS tiers, okay? So let's say that this user is now going to say, cool, can you tell me what the IP is of gslb.foo.com? And it's going to be sent over here. This is where it gets interesting, okay? Because this tier of intelligent DNS is constantly monitoring the back end, right? It's constantly monitoring. This allows you to have a lot of control over how you treat that user traffic, okay? So you can do things like, for example, route a user based on their geolocation, right? Based on their source IP, we can route them to a specific data center. You could route them based on what data center is going to give that user the best performance at that moment in time, okay? You can configure this in a lot of different ways that allows you to have control, but ultimately what's going to happen is the user's DNS request is going to be sent to that intelligent DNS tier, and that intelligent DNS tier is constantly monitoring, and then based on your configuration of what the best path is for that user, this DNS is going to simply respond with the IP address. It's going to resolve to the IP of whichever data center makes the most sense to send that user's traffic to at that point in time. And at that point, the process is over, right? Now we just go back to basic kind of unicast routing. The user's going to have a specific IP address, and they're going to start calling out directly there, okay? One thing I want to highlight here is the process of resolving DNS for the user may seem like, oh man, there's probably a lot of overhead. There's a lot of steps there. Well, remember, this is all based on DNS. Super, super lightweight protocol. And usually that user's DNS request, even though it's hopping through a couple different locations, is going to be resolved sub-second. And once the user resolves the DNS request, that they're all set, right? It's just unicast routing. So the point I'm trying to make is it's really quite efficient, even though this DNS process does have a few different steps. From the end user's perspective, it's lightning fast, and this allows us to route users to whatever instance of an application is going to give them the best experience at a moment in time. So there's a few pros and cons to this. The only real con is that you have to configure the DNS somehow. So you have to account for the DNS load, and you have to either automate or manually configure the DNS entries to perform that DNS action that I just explained. But the pros far outweigh the cons with this sort of design. You have full flexibility. We support a bunch of different use cases when you use this design. Multi-cloud infrastructure are supported. You could have it in an application be both on-prem and in a public cloud at the same time. It's highly distributed. You can do geo-based routing, performance-based routing of that user traffic. You can even have some security controls into that sort of response process that you need for your global server load balancing DNS process. And like I said, it can fill a lot of different use cases. We're not talking about CDN just yet, but absolutely you can use this technique to build out your own content delivery network as well. Okay, solution number 2 that we're going to discuss is a solution called service mesh. There's a lot of different service mesh solutions. So specifically, I'm going to be talking about a service mesh called Tanzu Service Mesh. This is a VMware SaaS-based solution. The cool thing about service mesh is underneath, it's actually the exact same technology from a site load balancing perspective that we just discussed with the global site load balancing or DNS, right? So effectively, the user traffic flow of, hey, I'm going to request my URL, and then that's going to be routed to the intelligent DNS tier, and then that's going to resolve to one of the IPs, whichever IP makes the most sense based on your configuration. That process stays basically exactly the same. The one thing that changes here, though, and the thing that's really interesting is that we kind of have this division of duties in a solution like this, where you have your platform team or maybe your infrastructure team managing the service mesh solution, and then you have developers developing software within, in this example, a Kubernetes cluster. So because you have this division of duties, there's a lot of benefits, but what I want to focus on is the fact that it makes the process of adding a new site or updating a site or adding a new DNS record fully automated. Basically, what that means is as developers spin their applications up and down in various clouds, all of these DNS entries and all of these routing capabilities that we've discussed so far are automated into the developer's build process. And it still allows us to build these globally distributed applications without having to slow down or have an intense amount of communication between developers and infrastructure operators. There's some pros and cons here too, right? A big thing is automated out of the box, okay? You just kind of plug the service mesh into your DNS load balancing solution like Avi Networks, and it's going to kind of just start working. The developer freedom, this is the thing I like to focus on, because this is where we're starting to unlock human potential with a solution. And in my view, making technology work is pretty cool, but if you can make technology work and at the same time unlock more human potential and allow more productivity to happen within your organization, that's what we should be striving for 100% of the time. There's a bunch of other great service mesh goodies. Of course, this is a hybrid cloud and multi-cloud supported solution because it's by VMware. Most of our solutions are these days. There's just a lot of other great benefits of service mesh, like security and other controls. So if this sounds interesting to you, definitely do some searches and do a little more research, because it's a really fascinating solution. On the con side of the house, there is some footprint that you have to deploy to make this system work. And because of that, it's oftentimes today anyway, a fit for really large organizations that have global scale infrastructures like we've been discussing. And for now, you do need some Kubernetes competencies to make this thing work, okay? My understanding is in the near future with this solution, you're going to be able to do all of the same stuff we just discussed, even with VM-based workloads. But for now, specifically the TSM solution is really focused on those Kubernetes and modern applications use cases. Okay, now I'm going to talk to you about another availability option, and this is called Anycast routing. Okay. Now, this is an interesting solution. This is not a solution you can really buy. Okay. This is a solution that you either have to build by yourself, so you need a team of network engineers to put their heads together and work on this, or you're going to consume it from a cloud provider like, for example, GCP. I need to kind of unpack this one a little bit because there's a lot going on here. All right. So, of course, one thing that doesn't change is you still need infrastructure. So there's going to be an on-prem or a public cloud compute infrastructure that you're leveraging with either Kubernetes or VM-based applications, most likely. You don't have to have a CDN or an edge tier, but usually if you're building an Anycast network, that's the kind of use cases it's targeted at. So this means you oftentimes are going to have a few data centers and an even larger number of edge points of presence. So that way we can route users to an edge POP that's really close to maybe their home or their region where they're accessing your app from. The way this system works is actually just leveraging good old BGP. All we're really doing with this solution is advertising the same IP address from multiple places at the same time. Okay? That's literally all this is. There's no intelligent DNS. There's no kind of decision-based routing. It's all based on what the kind of open, dirty internet says to do with the traffic at that point in time. So a lot of times, especially if you're going down the CDN use case, you're going to have a sort of caching tier at these points of presence as well. And this is why this sort of solution is oftentimes used by like a Netflix or like a Google or a really large scale organization, because they need really high performance and they need to be able to deliver content quickly and cheaply. And sometimes storing the content geographically close to the user that's requesting it comes with some performance and some cost advantages, because you may not have to send every request back to the data center. Let me give you an example of that. Let's say that this is a Netflix application and I'm a user in Boston and I hit a point of presence right here in Boston. Well, what Netflix will actually do is, let's say it's Tiger King, right? They'll go ahead and preload Tiger King with a cache here at the edge. So that way, when the user starts streaming Tiger King to their iPhone or their application, they're not having to go all the way back to the source data center to pull that file and stream Tiger King. It's just stored here at the edge, and we can store that at multiple edges at the same time. So what will happen is Netflix will oftentimes store the most popular content in these points of presence, so that way users don't have to go all the way back to what we call the origin to pull that traffic and put stress on the core data center application that Netflix has built. That's just an example, by the way. I don't actually know if Netflix uses Anycast or DNS, because what I'm describing here, this idea of caching, can absolutely be done even with a DNS-based solution. It is in no way exclusive to Anycast. Anycast is just one option that you can use to deliver this sort of an application. So again, CDN and streaming use cases are fairly common to see with this sort of a design, and generally, you're going to use a cloud managed service to do this. Google Cloud has something called their global load balancer that offers an Anycast service. So that's a really easy way to spin this up, okay? But the downside of that is you're generally going to be locked into that cloud if you kind of go all in on their Anycast or CDN solution, or you'd have to engage both that Anycast solution and DNS over the top to spread it across multiple clouds. There's a bunch of cons. I'm not going to go through all of them. One thing I like to point out, though, because I've got a networking background myself, is that if you're using BGP, an AS hop is not equivalent to performance, right? BGP doesn't care about application performance. It only cares about network hops. And so it doesn't necessarily always mean that your user is going to be getting the best experience just because you're using Anycast. Another good thing to point out is if you need to manage an Anycast network on your own, it's a pretty heavy lift. You need to own at least a /24 IP block, and you need to get permission to advertise that IP block from a number of different locations. So not necessarily a bad thing. It's just there's some regulations you have to worry about. You certainly need to be registering with different organizations and probably coordinating with multiple service providers. That means that there's a lot of complexity here that if you use a DNS-based solution, just doesn't exist. Okay, and here is the final design that we're going to discuss. This design, it has a few different names. It's changed over time. Some people might call this a Metro-Datacenter design, layer 2 stretch, active-active data center clustering. But effectively, what this is taking multiple physical data centers, and I must take note, by the way, you cannot generally do this in a public cloud. This is going to be something you build in your own infrastructure, okay? This allows you to take multiple physical infrastructures and kind of abstract the networks in a way to where, even though these are two separate sites, they operate as one logical network. So we would be advertising, very much like Anycast, the same IP space from both sites, and your VMs or clusters, the application behind the scenes is operating just like it normally would, but it's actually kind of clustered between these two data centers. So in this design, an application can move from one physical data center to the other, which is pretty cool from like a availability perspective. And what I'm seeing more and more lately is that customers and organizations are using designs like this to build their own availability zones within regions, right? Because, this idea of clustering data centers, it is definitely regional. You couldn't cluster a data center in the United States with a data center in the Asia Pacific. It wouldn't really work from a latency perspective. There's a lot of technical challenges, but you can cluster together data centers within geographic regions to do something a little bit like this. So what you can do is take that idea of clustering two logical data centers together to build out your own availability zone structure within different regions. And that's excellent because what you can do is leverage both the concept of these clustered data centers, so having your different availability zones within physical infrastructures, but on top of that, you can leverage that DNS-based load balancing or global site load balancing. So that way you can route users to different physical locations based on DNS, but also ensure that these different physical locations are highly available in a different way than just DNS. So now if I lost this availability zone 1, well, generally in a design like this, what's going to happen is all the systems that are over here are just going to pop online in the second site, and the users are none the wiser. So this is definitely a pretty complex design. This is something that some organizations use. I've seen particularly like large financial institutions using this sort of design that have large on-prem footprints. But it's just worth noting, this could absolutely be overkill for what a lot of organizations are doing, but it's nice to know that it's a design option, and it's definitely something that's used by a lot of large organizations. Okay, from a pros and cons perspective, right? One significant pro of this is that if you have kind of an older application that you can't rewrite, there's this concept we call IP mobility. It's the idea that you can move a VM between physical data centers without having to change the way the system works. This is great for old apps that you can't rewrite or you don't want to invest in rewriting, but you still want some kind of availability for, right? This is also a solution that's managed by the infrastructure team, and the whole availability zone thing can be largely somewhat transparent to the application. The thing to note of all the solutions we've discussed, this is the only one that can both be globally available and regionally available, okay? So, the idea of using the clustered data centers or metro data centers, I've seen this used very heavily in like municipal governments because they have oftentimes regulations where they're not allowed to have data centers outside of their state, for example, okay, or outside of their nation. And if you have a regulation like that, the reality is, you can't have global scale infrastructure because there are regulatory requirements preventing that. So, in that case, having that sort of inter-region availability can be very helpful for organizations that still want to ensure their applications are really resilient, but also are unable to scale out globally. Now, of course, you could still just use DNS load balancing within a single region as well, but there are different design options available to organizations. On the con side of the house, there are some issues around tromboning traffic, so you do need a high-speed, low latency interconnect between your data centers to make the availability zones work. And that does mean that you're sending traffic back and forth between the data centers. So you really need to ensure that that if you're tromboning traffic over those links, that it's not going to be an issue. Okay. You definitely need some network engineers to make this thing work. All right. You need somebody with IP competencies to ever begin thinking about a solution like this and managing it by yourself. There are some challenges with traffic asymmetry. Today, there's a lot of stateful systems that you see in modern data centers, like firewalls and some load balancers, some kind of legacy solutions. But at the end of the day, those are something you have to consider. And then, of course, there are some scale limitations here within the region. Anyway, you can build as many regions as you want, but there is going to be a max for the number of availability zones that you can generally create within each region. All right, everybody, that's all I got for today. I hope this was useful. Of the designs I've discussed, I've been fortunate enough to work on most of them at some point in my career. So if you have any questions about the designs that I discussed and you want to have a deeper conversation about how those work, please feel welcome to reach out to me. I'd love to have a discussion. It's a very, very fun topic. That's all I got, everybody. I hope it was informative. Thanks for watching, and take it easy. Bye.